Hi guys, welcome to lesson 2, session 1, the area of a triangle. Today we're going to be solving this problem. It says, before we get started there, it's on page 21 of our book, so we need to be on page 21 before we get started. I'm going to read this question to you. You're going to pause the video. You're going to try this problem on your own. The question says, Caitlin has two decals shaped like the triangles shown. She arranges them on the back of her skateboard to form a parallelogram. Each grid square represents 1 square inch. What area do the two decals cover? So what do I notice about this problem? I notice that it says she's going to arrange these triangles. So even though we're starting with triangles, it says she's going to arrange them to form a parallelogram. I wonder how we can do that. You want to think about that while you're doing the problem. It also says that we're working with 1 square inch. That tells us the size of each square. And it's asking us what area do the two decals cover. So we have two triangles here. It says she's going to make them into a parallelogram, and then she's going to find the area. Pause the video here and try to do this problem on your own in your book on page 21. After you've tried it, we're back on the video and we're going to give this a go. So let's see. You may have again tried to count each box to estimate the area of both triangles. Now you can do that, but remember, counting boxes is not accurate. It only gives you a close guess. It won't rarely, especially when we're talking about these kind of like half squares, you're not always going to get the correct answer by counting squares because it's not accurate, right? It's not giving us, we have this one little guy here, there's a tiny little piece here, so you're not going to get the correct answer by counting. So what can we do? Well, the first thing we need to decide is how did she take these two triangles and make them into a parallelogram? To show us this, I have some cutout triangles of this same problem. So these are her two triangles. They're exactly the same. I'm just going to put them down here, one on top of the other. You'll notice that these are the same exact triangles, just like Caitlin's. Okay, so if I put one on top of the other, it disappears because they're exactly the same. Kind of like if you were to lay down on your shadow, right? It would disappear. So here we go. How can I rearrange these to form a parallelogram? To arrange something, I might just start putting it together in different pieces and deciding, is that a parallelogram? No. Is that a parallelogram? No, it's not, right? We don't have any parallel lines going on here. They touch each other, they intersect. And let's see, maybe this. Maybe you're starting to see where I'm going with this. Also not a parallelogram. Keep moving. These sides look like they line up, right? They're about the same size. So if I put these two sides together, what do I get? A parallelogram. The reason I know it's a parallelogram is that it has opposite sides that are parallel and equal in length, right? This line will never, ever, ever touch this one. And this line across the top will never, ever touch this one. They're also the same length. I can tell that by lining up the sides. And actually, when I do that, I even get another parallelogram. When I line up these sides, my other last two sides, to see that they're the same length, I again get another type of parallelogram. I'm going to stick with this one for now. Notice that no matter what shape these triangles are in, that I'm not adding or taking away any part of the shape, right? I'm just moving it. I'm going to put that aside for now. We're going to come back to our books. So what this is telling me is that I was able to take this edge of my triangle and line it up with this one. Now that I'm looking at it again, I'm noticing that those are the same length, and it makes sense that they would go together like a sandwich, right? So what I'm going to do is I'm just going to redraw my shape. It might not be perfect. In fact, it won't be, but I'm just going to draw this parallelogram out. Maybe this would have been about here, something like that. We just want to look at our one parallelogram. In fact, I'll even keep that. So now that I have this, I have a parallelogram. I can use my formula now, area equals base times height, right? I couldn't do that with my triangles. They're not parallelograms. This would not work for a triangle. But I can use it for a parallelogram. Now I have one. So what do I need to do? I need to find my base, which will be purple, and I need to find my height, which will be blue. So let's do that. All right, what's my base? Remember, our base can be any side of this parallelogram. Take a minute now to see if you can find the base by pausing the video. Once you found the base and you're back on the video, you'll see that it can be any of these four sides, but I'm going to pick this bottom one because it's on the bottom, and I just think that that's easier. There's my base. I'm not going to worry about the length yet. Let's find the height first. Pause the video now. See if you can find the height. Remember, what do we know about height? Height in a triangle goes from the base to the opposite vertex, which is a corner. Any corner of a shape is called its vertex. The height of a triangle goes from the base of the triangle straight up to the opposite vertex. Okay, so I am working with triangles here, but I'm also working with parallelograms. I can kind of see my triangles in here, but we're just looking for the height. Take a moment now to find the height of this triangle, of this parallelogram, excuse me. After you try it on your own, you're back on the video. We're going to find our height. So I know for a parallelogram, I'm going to start at the base and I'm going to draw a perpendicular line to the opposite side, right? We have to remember we need that right angle. If you forgot this right angle, make sure you go back and check your work. You have to have that perfect L or T shape for it to be correct. And now I said parallelogram this time, but if you look, I'm going to shade in just one of our triangles here. Right? You'll notice that it is going from the base to the opposite vertex. So what would that look like up here? Take a second now to see if you can draw the height in on these triangles up top. The height of a triangle goes from the base to the opposite vertex. You could also say the vertex perpendicular to the opposite base. Either way, there's our height. So what is the height of our triangle? If you said 6, I want you to look again. The height of my parallelogram goes from here to here. I can see that this is just one of my triangles that I'm working with. What is the height of the triangle? The height is 3. Right? I know that because up here we have 1, 2, 3. Okay? Well, we got the hard part out of the way. Height is harder than base, so let's look for our base. Our base we said was purple. It's on the bottom here. What is the length of my base? Well, looking up here again, right, I noticed that this is that long side that I'm using for the base. So I'm going to go ahead and count my squares. I have 1, 2, 3, 4, 5, 6, 7, 8, My base is 8. Now I'm going to plug this into my equation. If I'm using A equals base times height, I know that I don't know my area yet. I'm going to leave my A there. Area is equal to base, which is 8, times height, which is 3. I'm going to use my multiplication skills and find my answer of 24. Now, this answered my question, right? The area of my two decals is base times height, which is 24. But that only worked because it was a parallelogram. Remember, this would not work for triangles. So I'm going to leave you with this question. If together these triangles have an area of 24 centimeters, sorry, we're using inches in this problem. If both triangles have an area of 24, then just one triangle has the area of what? Keep pondering that question. We'll go over it together when we're in class. Good job, and let me know if you have questions.